A big question: what is beyond the edge of the universe? Where does the end of the world lie? What shape does its edge have, and what, if anything, is outside its boundaries? These questions become more than just interesting as our made-up rocket moves forward. They test what we know about physics, space, and time. The idea of hitting the edge of the universe raises many questions about the shape of the universe, whether it's flat, spherical, or something else, and the nature of the universe itself. Would the world be infinite, going around and back again so we could end up where we began? Or does it have a clear endpoint? In this case, we are forced to think about the role of dark energy in speeding up the growth of the universe. It brings up the idea of cosmic boundaries, places where the speed at which space expands is faster than light, blocking access to and knowledge of certain areas forever. It also opens up the chance of finding things that are beyond what scientists can explain, like structures or remnants from before the known universe. This trip to the edge of the universe is more than just a physical one. It's a deep exploration into the unknown that makes us think about what will happen to the universe in the end and where we fit in it. Our speed through space will try the basic rules of physics that we know, like relativity, quantum mechanics, and the ideas that explain how the universe is expanding. This trip is an odyssey into the heart of cosmic mysteries. It's a quest full of unknowns that could change the way we think about the world. After starting a made-up trip to the edge of the universe, we'll now look more closely at the main mysteries that have stumped people for hundreds of years. 3 basic questions that are at the heart of modern cosmological research are answered in this movie. Does the universe have an edge? Can it really go on forever? And what shape does the world really have? These aren't just intellectual thoughts, they have deep roots in physics and will change the way we think about the universe in big ways. The idea that the world has an edge makes me think of a limit, a boundary, that there is nothing beyond. This idea makes us think about what lies beyond the edge of the universe and questions how we think about space and time. You could also say that the universe is infinite, which means it goes on forever in every direction and is made up of matter, energy, and space-time itself. This idea changes how we think about the universe as an infinite thing, where size and distance have new meanings. The shape of the world is both strange and important. It controls the general shape and development of the universe, affecting everything from the expansion of the universe to the ultimate fate of all matter in it. Does the world have a smooth, almost imperceptible curve that goes around and around? Or does it have a curve that goes around and around, making a closed system with no beginning or end? Your participation becomes an important part of our journey as we look into these cosmic puzzles. By giving this movie a like, you tell the algorithms that this search for the secrets of the universe is something that other people should see. Every like, comment, and share moves this conversation forward and encourages more people to think about the infinite depths of our world. Come with us as we explore the unknown and try to find answers to questions that have fascinated people since the beginning of observation and theory. This is more than just a trip through space. It's an adventure into the very core of being. With its groundbreaking findings, the James Webb Space Observatory has opened up a whole new world of wonder for us to explore in the universe. This cutting-edge space telescope, a real work of modern science, has found what seems to be proof of dark time, a time in the past of the universe that no one knew about before. This discovery challenges the very basis of current cosmological models. The main idea behind this finding is that galaxies have been seen that, based on what we know about science now, shouldn't exist. Even though they were only made 600 million years after the Big Bang, these galaxies were surprisingly old. Our current models tell us that structures this complicated would take a lot longer to form, so this timeline is very different from what we thought. The sheer size and age of these galaxies suggest that the timeline of the universe may be much more complicated than we thought before. People have named this period in the early universe dark time because it seems to have been ideal for galaxies to form quickly. According to this idea, the universe may have gone through times of fast evolution that aren't fully explained by current ideas. If it turns out to be true, dark time could completely change how we think about the past of the universe. We would have to rethink how the universe formed and how it is expanding. This find has very important effects. It not only throws into question the commonly accepted timeline of the universe's history, but it also suggests that basic parts of our models of the universe may need to be changed. What the James Webb Space Observatory has found could lead us to a world that is much older and more complicated than we thought. As we try to figure out what these observations mean, scientists are on the verge of coming up with ideas that could change the way we think about things. We need to rethink what we thought we knew about the universe because of this finding. It creates new areas for study and debate. The idea of dark time and what it means for our knowledge of cosmology shows how mysterious the universe is and how much we still need to learn about it. The James Webb Space Observatory has revealed more mysteries about the universe. The finding of galaxies that seem to have appeared out of nowhere has made us rethink how we know about the history of the universe. This discovery is just a strange event. It's a clear signal for theoretical cosmologists to start over. These galaxies, which were fully formed a lot earlier in the history of the universe than we thought possible, throw a wrench into the workings of our current models. At the heart of this problem is what we know about how old the world is and how its structure has changed over time. The models we have now, which are based on studies of cosmic microwave background radiation and calculations of the Hubble constant, might only tell us part of the story. Discovering these early galaxies suggests that the universe may be older than our calculations show, and that the formation and growth of galaxies may have happened in ways that our current theories don't explain. This situation makes me change my mind about a lot of things. The field of theoretical cosmology is on the verge of coming up with truly groundbreaking ideas that could change the way we think about dark matter and dark energy. The mysterious parts of the world that control its structure and growth may work according to rules or schedules that we don't fully understand yet. Also, the idea of dark time, a time in the early universe when galaxies could form quickly, makes people wonder about the very structure of spacetime and the forces that were at work in that time. Could there have been conditions or processes that made galaxy formation easier than we can explain with what we know about physics now? This unexpected trip into the deep past of the universe makes cosmological ideas need to be looked at again from a wider perspective. It's an important moment that shows how scientific research is always changing and growing. As we learn more about the universe's mysteries, we are aware of how much we still don't know. This makes the age mystery of the world call us to keep looking into it, asking questions, and exploring. The James Webb Space Observatory's find isn't just a sign of how smart people are and how much they want to learn. It's also a piece of the big picture of the universe that may change how we think about the very nature of the universe itself. Stay tuned as we continue to look into these discoveries. Every answer we find leads to new questions, so we're on a never-ending quest that could change the history of cosmology. The idea of the visible universe, which is made up of the farthest places light has had time to travel, is both interesting and hard to understand. Because the speed of light is limited, we can only see so far into the universe. This speed, which stays at 299,792,458 meters per second, means the visible universe is not a vast, unending space. Instead, it's a bubble that starts at the observer and goes out about 46.5 billion light-years in every direction. This line doesn't stay the same. It gets bigger as the world ages. Every second, this limit is pushed a little further, revealing parts of space that had not been seen before. But this expansion isn't just about distances getting farther apart. It's closely connected to the expansion of the universe, which comes from Edwin Hubble's finding that galaxies far away are moving away from us in all directions. This growth makes it harder to figure out where the limits of the universe are. This means that, because space is expanding, it looks like galaxies are moving away from us faster than they really are. The general theory of relativity predicted this effect, and redshift observations have shown it to be true. It means that there are parts of the universe that we will never be able to observe. Not because the light from those parts hasn't reached us yet, but because space is expanding too fast for that light to ever catch up. So, the boundary of the observable universe isn't just the edge of what our instruments can identify right now. It's the very edge of the universe that we can't see or possibly even know anything about. Now we reach an exciting point. The edge of the universe that can be seen. But what's beyond this edge of the universe? Are there structures, galaxies, or even whole parts of the universe that will always be a secret? Because space is expanding so quickly, we are on the edge of this huge unknown, which makes us question everything we thought we knew about the structure and size of the world. The idea of an observable universe forces us to face the fact that our little corner of the universe is a very small part of a much bigger and more beautiful universe. What mysteries are beyond our present ability to observe? It's possible that the universe is even more complicated and amazing than we thought. Join us as we explore beyond what we can see and test the limits of what we know and what we can imagine. The true size of the world and the mysteries it holds are still one of the most interesting things to study. Beyond could change our view of spacetime and even our own existence, changing where we fit in the universe. We want to explore one of the most interesting events in theoretical physics and cosmology by going on this intellectual journey on our made-up spaceship. As our rocket speeds up to the speed of light, our trip to the edge of the universe stops being just a trip through space and turns into a deep dive into the nature of reality itself. In this thought experiment, we enter a world where Einstein's theories of relativity are not just ideas, but real things that the people on our spaceship would experience for themselves. Because the ship is moving faster, the effects of special relativity become stronger. The spaceship would stretch time, meaning that time would seem to move more slowly for those on board than for people watching from Earth. This event, which has deep roots in the structure of spacetime, makes us question the idea that time is a constant. The idea of hitting the edge of the universe also makes us think about the limits that the expansion of the universe puts on us. Because dark energy affects the universe as the rocket goes farther, it will find parts of space that are expanding away from it faster than light. Because the space between the spaceship and the horizon is growing too quickly, the spaceship will never be able to reach it. It's a strange idea that goes against what we normally think about speed and distance. This trip also makes me wonder what lies beyond the visible world and at the very edge of what we can see. If there really is no end to the universe, the spaceship would never really hit an edge. Instead, it could go around and around in a circle if the universe has a closed shape, or keep going forever if the universe is growing. This story presents the idea of a universe where edges and boundaries don't refer to physical borders, but to the limits of what we can see and measure. As our spaceship tries to make this huge trip, it becomes a symbol for the search for information in general. There are a lot of mysteries and uncharted areas in the world, which makes us think and be creative as the spaceship tries to reach the edge of what can be seen. In the same way, we are always trying to push the limits of what we know and what we can understand. This thought experiment not only shows how hard it is to travel at relativistic speeds, but also makes us think about what it means to explore a universe that may not have any basic limits. It makes us think about how we fit into a universe that is much stranger and more amazing than we ever thought possible. Our cosmic boundaries are shaped by the universe's growth, which is powered by the mysterious force called dark energy. This never-ending growth not only stretches space, but it also shows us the edges of what we can see in the world. Dark energy makes the universe grow faster and faster, and it also makes a cosmic boundary that light hasn't had time to reach yet. This line isn't fixed. It moves as the universe grows, making the universe bigger to see, but also making what's beyond it even more mysterious. The effect of dark energy on the growth of the universe makes it much harder for us to study and understand the universe. It splits the universe into concentric rings, with the universe we can see in the middle and places we will never be able to reach around it. The parts of the universe beyond what we can see are not only not visible, but they are also physically impossible to reach because they are expanding faster than light. This expansion creates a cosmic horizon, which is a line where the rate of expansion is faster than light. Things past this horizon are going so fast away from us that their light will never reach us. This horizon is not a physical wall, but rather a limit set by the way the world is expanding. It contains the observable universe, a limited spacetime bubble from which we can receive data. It is surrounded by an incomprehensible space that we can't see. When we think about how big the world is and what dark energy does, we can't help but wonder what will happen to it in the end. The fast expansion makes us think that, in the far future, galaxies beyond our own will fade into the vastness of space, their light becoming less bright and finally disappearing from view. If this happens, the universe will become more and more alone and empty, with dark energy taking over and stars from faraway galaxies disappearing into the darkness. When we look into the infinite space of the universe, we are filled with deep questions about our place in this ever-growing universe. What does the universe's future hold? And what does it mean for our memory and the vast space we call home? The fact that the world is going into empty space means that we have to look into these existential questions more. Stay with us as we look into the end of the universe and try to figure out what its growth means and where all the matter in it will end up. There are a lot of galaxies in the universe, and their lights give us a brief glimpse of how big it is. Dark energy is pushing the universe ever further outward, and many of these galaxies are moving away from us so quickly that their light will finally not be able to bridge the ever-widening gap. This effect creates what are moving called farewell photos, the last pictures of faraway galaxies before they fade away beyond the edge of what can be seen in the universe. These galaxies were once visible, but now their light is taking them to places that can't be reached, putting a cosmic timer on their visibility. This idea brings out a deep and somewhat sad truth about how the world is expanding. Because dark energy pushes galaxies away faster, they take with them stories of how the universe began, how it grew, and how it will eventually fade away. The farewell pictures are a cosmic goodbye to parts of the universe that we could see before but will soon no longer be able to. This will leave the universe more and more alone and empty. The long-term effects of the universe's growth are very dark. They range from the idea of farewell photos to a future dominated by empty space. In this future, dark energy pulls the fabric of the universe ever further apart until matter that can be seen is nothing more than a rare relic in an ocean of empty space. This never-ending expansion predicts a universe where galaxies beyond our local group are so far away that their light can't be seen because the universe is expanding so quickly. In this kind of world, the local is very important. When the Milky Way, Andromeda, and other nearby galaxies join together, they might stay as an island universe, a safe haven in a sea of dark energy-driven growth. This situation imagines a universe where the only stars and galaxies we can see and study are those that are close to us. Dark energy is the main force in the world, and it goes on and on into an almost unimaginable void beyond this point. This move toward empty space makes us question what will happen to the world. It makes me think of a future where the universe isn't filled with the light of a million stars, but is instead a quiet, dark space with a few islands of galaxies here and there. The universe's complex web of galaxies fades into the background in this far-off future. What's left is a universe that is marked not by the objects in it, but by the dark energy that holds it together. Let me know what you think about the shape of the world and the idea of higher dimensions.